Hey, welcome back to your favorite trigonometry class. We're going to take a look at analytic trig in this unit, specifically this section 7.1, inverse sine, cosine, tangent functions. Let's talk about the sine function first. Let's go ahead and think about our graph again of the sine of x, where we have the sine of 0, 0, sine of pi 6, 1/2 sine pi fourths. We got root 2 over 2 sine pi thirds. We got root 3 over 2 sine pi halves is 1. Let me go in the negative direction here. Negative sine of negative pi sixths. We've got negative 1/2 sine of negative pi fourths, negative root 2 over 2 sine negative pi thirds. Finally, sine negative pi halves. Negative 1, so if we're graphing this, sine 0, 0, sine pi halves 1, sine pi 0, sine 3 pi halves, negative 1, sine 2 pi 0. Alright, so we have the old sine function. Now, we're talking about the inverse sine function. So if you remember from pre-calculus, you have an inverse if, number one, it's a function, which the sine is a function because it passes the vertical line test. In other words, for every input, there's one output. For every x, there's only one y. So it passes the vertical line test. So that's a check mark. The second requirement to have an inverse is it has to be 1-to-1, which means for all a and b in your domain, f of a cannot be equal to f of b. You can't have the same y values for different inputs, a and b. F of a cannot be equal to f of b. So for example, like y equals x squared is not 1-to-1 because, for example, at 2 you have the point 4, and at a different input, negative 2, you also have the same value for it. So it fails. The horizontal line test is the test to see if a function is 1-to-1. So this is not 1-to-1. So is the sine function 1-to-1? No, it's not either because it fails the horizontal line test. So this is not 1-to-1. So the sine function does not have an inverse. But what mathematicians did is they're like, you know what? We want it to have an inverse. Why don't we restrict its domain? Between negative pi halves and pi halves. Why don't we restrict its domain between negative pi halves and pi halves? So we'll only go from here to here. So now it's 1-to-1. It's a function and it's 1-to-1. So the domain was restricted. This is a big deal. We restricted it in order to have an inverse. So its domain is now from negative pi halves to pi halves. Its range is from negative 1 to 1. Now, if you remember, the way that you algebraically found an inverse is you switched your x and y. So instead of y equals the sine of x, you switched your x and your y. And then what you did is you solved for the new y. Okay, so the way that you undo this is you undo it with what's called the inverse sine, so the arcsine, and it undoes it. So this is the inverse of the sine. This is called the arcsine of x, arcsine of x, or is the inverse of the sine. Okay, so it's the inverse of the sine. What that means is all these points, like pi halves 1, are all going to be flipped around because the inverse function So instead of pi halves 1, you're going to have 1 comma pi halves. Instead of pi thirds root 3 over 2, we're going to have root 3 over 2 comma pi thirds. So all these points flip around. And the old range becomes the new domain. So now the domain will be, the old y's become the new x's. The old x's become the new y's. So the domain here is from -1 to 1, and it goes from negative pi halves up here to pi halves. And so you plot these points, instead of negative pi halves -1, I got -1 negative pi halves right here. 0, 0 flipped rounds right there. Instead of pi halves comma 1, I got 1 comma pi halves right here. Oops, come on. Right there. Anyways, you plot all those other points, use the decimal approximations, like pi thirds, this is 1.047 and so on. Use your basic scientific GP calculator to kind of help you graph those. But this is kind of what this thing looks like. Okay, this is the inverse function. Inverse, and we denote it, that's the inverse of f. If this is original f of x, this is the inverse of f. Okay? So there's just another picture of that. So again, they flip-flop x's and y's. So if y equals the arcsine of x, then the sine of y equals x, right? They flip-flop. So let's do an example here with that understanding that the x's and the y's flip-flop. So for example, if the arcsine of -1, if I was to find the exact value of that, what I'm going to do is I'm going to let it equal theta. I'm going to say, well, if that's true, then I know the sine of theta must equal -1, right? For example, if the sine of pi 6 is 1/2, so in other words, you have the point pi 6 comma 1/2 on the graph, then the arcsine of 1/2 must spit out pi 6 because the x's and the y's flip-flop. So the point would be 1/2 comma pi 6 for the arcsine, right? So that's all this is saying. I'm saying, well, I'm going to let this be equal to theta. And then I'm going to say, if this is true, then the sine of this as the input would be that as the output, right? Sine of theta would be -1. But this is only where theta is between negative pi halves and pi halves, right? So I can only look between negative pi halves and pi halves, and what I'm looking for is I'm thinking to myself, well, the sine of what is -1 on my unit circle? I have a sine of what angle, right? What angle? And I say, oh, it's right here. That's where I have a sine value that's -1. What is that angle? Oh, negative pi halves. The sine of negative pi halves must be -1. So, what's that saying? Well, that's saying theta has got to be negative pi halves. And remember, I can only look between those angles there, between negative pi halves and pi halves, because I had to cut off the original sine function in order to have an inverse, right? Okay, so theta must be negative pi halves. We just found theta. Hence, the arcsine of -1 equals theta, but we just found theta. It must be negative pi halves. There we go. So the arcsine of -1 is negative pi halves. Let's do another one here. The arcsine of root 3 over 2, if we're finding the exact value again, set it equal to something, set it equal to theta. That means then, let me use its inverse, that means the sine of theta must be root 3 over 2. Again, but only for an angle between negative pi halves and pi halves. So again, I can only look for an angle between negative pi halves and pi halves. And so I'm looking for an angle, the sine of what angle? Sine of what angle is root 3 over 2? And I say, oh, well, which angle has a sine? It's got to be right here, where the sine is root 3 over 2. Is that angle right there, which we know that angle to be what? Pi thirds. Pi thirds. I know the sine of pi thirds is root 3 over 2. So theta must be pi thirds. We just found our answer. So the arcsine of root 3 over 2 equals theta. What's theta? Pi thirds. Right? Arcsine of root 3 over 2 is theta. We just found theta, pi thirds. All right, could we find it with a calculator? Sure, just find your arcsine. Let me do it in decimals here. Find your arcsine. Go to your, where's it at? Scientific calculator. Punch in function, arcsine. Make sure you're in radians for this one. This is 1/3, I think it was. The arcsine. Let me see if I can find what was it. Yeah, 1/3. So we got 0.33 there. There's our answer right there. Again, make sure you're in radians. Right? Make sure you're in radians. Or you could do the arcsine of negative 1/4, negative 0.25268, blah, blah, blah. Keep going with that. Make sure you're in radians. Notice there's no little degree mark there. All right, how about the inverse of the cosine? So if you think about cosine, oops, get my pen here. Think about your cosine for a minute. Cosine of 0 is 1, cosine of pi halves is 0, cosine of pi is -1, cosine 3 pi halves is 0, cosine 2 pi is 1. So we got this cosine function. As we keep going with that, we got our cosine function. Now again, does this have an inverse? Well, it's a function, passes a vertical line test, but it is not one-to-one. It fails the horizontal line test again, just like the sine function. But the mathematicians say, you know what? We still want to have an inverse. We are greedy. We got to have an inverse. But we can't do it between negative pi halves. I'm sorry, here, we can't do it between negative pi halves and pi halves because it still fails the horizontal line test. So let's change the domain. And instead, let's do it between 0 and pi. And let's forget about the rest of it. So we're just going from 0 to pi only. And let's forget about the rest of this. So only between 0 and pi. So let's restrict our domain between 0 and pi. So it's restricted again. Domain only between 0 and pi. The range, you notice, is between -1 and 1. So for its inverse, switch your x and y. So cosine of y equals x. Now we're going to run the inverse on that. We're going to call the arccosine, which will undo it. The arccosine, cosine of y just gives you the y. So here's our inverse of the cosine. So arccosine, inverse of the cosine. So all your x's and y's will flip-flop. So the old y's, the old range, will become the new domain. So the domain will be between -1 and 1. The range will, instead of being the old x's between 0 and pi, will become the new y's between 0 and pi. So we're from -1 to 1, and we're from 0 to pi. So instead of 0, 1, right, this point right here, I'm going to have 1 comma 0. Instead of pi -1, I'm going to have -1 comma pi. Instead of pi half 0, I'm going to have 0 comma pi halves right there. Anyways, I graph all these points, and I get a nice look at the inverse function, right? If this is f, this is f inverse. This is f inverse, which we call the arc cosine, right? All the x's and the y's flip-flop points on this one. But notice our domain, again, between -1 and 1 on this, okay? And the range between 0 and pi. And notice they're also reflective about, right? They're reflective about that line y equals x. So instead of pi -1, I got -1 pi, and so on. All right, so let's go ahead and similarly find some exact values, kind of like the arc sine. Let's do it for the arc cosine. See, the arc cosine of 1/2 is 0. Then we know the cosine of something has got to be a half. But this is a little different because this is where our theta, remember we had to find an inverse, we had to change we had to restrict the cosine between 0 and pi. So now we're thinking to ourselves, oh, well, then the cosine of what is a half? So if you're thinking about the unit circle, you're only looking between 0 and pi. Cosine of what is a half? Cosine of what is a half? And you say, oh, well, that's right here. I have a cosine. I have an x value that's a half, right? What's this rotation? What's this rotation? Theta is what? Well, theta's got to be pi thirds. I know the cosine of pi thirds is a half. Again, I can only look for that answer between 0 and pi. Cosine pi thirds is half, so that means theta has got to be pi thirds. Theta is pi thirds. So the arc cosine of 1/2 equals theta. What's theta? Pi thirds. Okay, so the arc cosine of a half, pi thirds. Let's do another one here. The arc cosine of -√3/2 is theta. That means the cosine of theta is -√3/2. Cosine of theta is -√3/2. Again, theta is between 0 and pi here. So I'm only looking on the unit circle here. So I'm thinking cosine of what is -√3/2. Cosine of something has got to give me -√3/2, right? In other words, cosine of some angle, right? I got to go to here. This is my angle that I need. Boom, there to there is -√3/2, and we say, oh, that's 5 pi 6. Cosine of 5 pi 6. Cosine of 5 pi 6 is -√3/2. So theta's got to be 5 pi 6. So the arc cosine of -√3/2 is 5 pi 6. Boom. All right, I'm going to stop right there. I'm going to do this in the next video. Thanks so much for listening. See you guys next time.